Hello, this is Professor Campbell. Welcome back. We are continuing our journey on rational expressions. We started our journey with simplify rational expressions, and the focus was being able to factor. Because if you can factor, simplify will be made easy. And now that we're into operations, we did multiplication, now we started division today. In order to cancel, to make your problem simpler, factoring is going to be an essential know-how. So let's go ahead and get started. I'm going to share my screen and we're going to do a brief review of what we talked about last class, and we're going to also review dividing fractions, because as you know, a rational expression is basically a fraction where we have expressions in the numerator and the denominator. And a fraction has a number in the numerator and denominator, but the concept as far as dividing these kinds of numbers, whether if they're a rational expression or a fraction, you have to follow 4 simple steps. Now I say have to because I believe in accuracy. So if you do it this way, it might make it a little bit easier. Now, the steps you need to remember, you're going to reciprocate the second fraction. And I share the word flip with my students because sometimes the word reciprocate can be a tongue twister, especially if you say it so many times. So I use the word flip a lot. Here again, as an instructor, I try to make things simple because I know math is a subject that many students struggle with. So I try to make it simplified so it won't be too much of a, oh, I don't like math kind of attitude. Anyway, after you flip or reciprocate a second fraction, you would change your division to multiplication. And you're going to cross cancel. And this is where I say that factoring is going to be important because you can only cross cancel expressions that are the same. Because any number divided by itself is 1. Same thing as any expression divided by itself is 1. So therefore, they can be able to cancel out. So if you're factoring correctly, you will see a lot of possibility of canceling. And here again, once you've done that, then you're going to multiply. Okay, so now I'm going to demonstrate briefly these steps using regular numbers, just to remind you how it works. All right, so let me find a simple fraction here, and I think I saw it earlier. Okay, here it is. Now, I am using a different style of writing. I'm not writing on my screen like I did in the past, so I hope that I don't mess up. And I'm messing up already because I can't even get to it. 3 halves divided by, remember it is 7/8. All right, that's our problem we're given. 3 halves divided by 7/8. Now, I'm going to do exactly what I said. Upstairs, above. I'm going to flip my second fraction. So my numerator goes to the bottom and my denominator comes to the top. And my division becomes a multiplication. My first fraction is still going to be 3 halves. So here I'm just demonstrating the changes that were done are in green and the original is still in red. I'm now going to cross cancel. I'm going to look diagonally, my 2 and my 8. 2 is an even number, and according to the divisibility rules, 2 can be divided into any even number. So I'm going to divide 2 into itself, which gives me 1. I'm going to divide 2 into 8, which gives me 4. Now, for clarity, I'm going to rewrite the problem, only writing what is not crossed out. Once I've done it, I can see clear how I'm going to need to multiply. So remember, with multiplying fraction, you can write numerator times numerator. That's 3 times 4 gives me 12. 1 times 7 gives me 7. And because we're not working with fractions as a concept, it's okay if we leave it as an improper fraction, but if we do reduce it, we reduce it to a mixed number, which would be 1 and 5/7. But that's just an overview of how you would actually do the same approach when it comes to rational expressions. So let us go ahead and jump in and see how we click on our worksheet, shall we? All right, let's start with a simple one where we're looking at monomial, a one-term polynomial. Okay, let's see a simple example we have. Well, it's not that simple. 5a cubed b squared over 24 divided by 10a to the fifth over 6. Now I'm going to do this the long way because I like to show students exactly what's going on. And that means, like I say the word factor, I'm going to factor everything that's factorable so I can be able to see common factors and be able to cross cancel. Okay, first of all, let's make our changes. Remember, division becomes multiplication. The second fraction is flipped. 6 becomes my numerator. 10a to the fifth becomes my denominator. My first fraction does not change, so it's still 5a cubed over b squared. B squared over 24. Now my next step, I'm going to go ahead and factor. Okay, so 5. A cubed means A. B squared means B. And it's still all over 24. So if we factor one, we might as well factor the other. And 24 can be factored into 4 times 6. And the reason why I'm using 4 times 6 because if I look diagonally, there's a 6 up there that will help me do some canceling. So that's why I'm using the 6. I'm going to write 6. I'm going to factor 10 into 2 times 5 because I see a 5 over there that I can cancel it. And I don't know if I'm going to be able to get 5 A's here. We'll try. Oh, I did it. Okay, 5 A's. Because a to the fifth is 5. Once we factor completely, now we're ready to do our cross canceling. Remember, you cancel diagonally or up and down, not across. Okay, so this 5 cancel this 5 over here diagonally. This A canceled one of these A's. This A canceled one of these A's. This A cancels with one of these A's. There's no B's to be canceled. My B is going to stay as is. 6 is going to cancel with this 6 over here. Now, again, for clarity, let's rewrite everything that we have left. Let me give myself some paper. On the first fraction, in the numerator, I have B. Oh, where am I? I have B. Okay. Erase that my paper is not cooperating with the camera right now. Okay, let's give myself some paper again. Okay, so we have 5. What is it doing? I'm not even touching the thing. Excuse me, I don't know why it's acting this way. It's being a bad boy. Okay, let's see. Why is it doing that? Don't want that. What? Let's just use my hand here. Five B over 4 times, there's no other number in the numerator besides 1, so we put a 1. In the denominator, we have 2 A. So to write our final answer, we would just multiply across. So it's going to be 5b squared in my numerator and 8a squared in my denominator. That's my final answer. And here again, I did it the long way, but there's a shorter way to do it. But whatever is going to be more accurate for you, I suggest you do it so you can see a positive result. All right, let's move on. We're going to look at another one where let's see where we can have a little challenge here. Okay, we have parentheses, x plus 2 that is squared, all over 10. Then we have it's divided by 2x plus 4 over x plus 2 squared divided by 10, over 10 divided by 2x plus 4. All right, what I notice here is a binomial being squared. And when we're talking about rational expression, remember you can only factor, or excuse me, you can only cancel if something is in factored form. So what I want to do is take my x plus 2 and write it in factored form. So I have x plus 2, x plus 2. I'm writing it in factor form so I can see factors, which will allow me to be able to cancel. 10 is just an integer that stays as is. I'm going to change my division to multiplication. I'm going to reciprocate, so I'm going to put 5 in my numerator. Before I write, write the next denominator, what I need to do to save myself some time, I'm going to go ahead and factor it. If I look at what I have 2, x, and I have 2. I'm looking for the GCF of both of those, and 2 is even. It divides into any even number, so my GCF is going to be 2. To get what remains in the parentheses, remember you're dividing your GCF into each term. 2 divided by 2 is 1, so that leaves the x. 4 divided by 2 is 2. By doing that, I can now see some common factors if I look diagonally. So this will cancel with this. I cannot cancel this 2 with this 2. When you see a plus sign, it's understood to be a stop sign. That's the way I label it to my students. Can say, oh, stop. Can't do that. In this particular problem, 2 is an add-in. It is not a factor, so it cannot be canceled with the 2, which here is a factor because it's being multiplied. So please be careful. Do not go inside of parentheses and cancel anything. That is not possible. But I can cancel the 5, divides itself once, it divides 10 once. I'm going to write what's remaining. So I have x plus 2 over 2 times 1 over 2. 2's across, cannot cancel. It has to be up and down or diagonally. I know I repeat a lot of rules a lot, but I think hearing it continuously will eventually stick in your mind where you know that's not something you do. So we're going to multiply across. Anything times 1 is that number. So 1 times x plus 2 is x plus 2. 2 times 2 is 4, and we are done. Here again, 2 and 4 cannot be canceled. So that is as far as we can go. All right, let's step it up a notch. All right, let's see. We have 6x plus 2 over x squared minus 1. And this is being divided by the root of 3x squared plus x over x minus 1. Okay, I want to know if you notice what I notice. You have to know your square root. First, give me a perfect squares in order to be able to identify things we see. If you look right here, that's difference of squares, ladies and gentlemen. You have to identify that to be able to know how to proceed. Once you identify it, you know how to factor it. So let's get into it. 6x plus 2. When you have difference of squares, difference of squares factors into sum and difference. Difference of square factors into sum and difference. So I suggest to go ahead and put your sum and difference, because you know that's how it's going to factor. That's a given. To find the term, you're simply taking the square root of each term. So the square root of x squared is x. You put 1 in each parentheses. The square root of 1 is 1. You put 1 in each parentheses. And you have factored difference of squares. And it's factored sum and difference. All right, we're going to change that to multiplication. We're going to go ahead and flip or reciprocate the second fraction. A lot of times I do not use the same process when working problems. Whatever I see first, that's what I zero in on. And the reason why I did the denominator first, because that was something that you should know from previous knowledge, difference of squares and how it's to be factored. Now, as I look at my problem, I notice that I still have some things that can be factored. Like, for example, my first numerator right here, I have 6 and 2, and they're both divisible by 2, so I'm going to pull out a 2. And when I do, I'm going to be left with 3x plus 2. FYI, before you proceed, always double check by multiplying back to make sure you come up with the original expression. 2 times 3 is 6. 2 times 1 is not, 2 times 2 is not 2. So that tells me right here, this should have been a 1. Okay? If you're paying attention. That's why I said just always go back and check. Now let's check again. 2 times 3 is 6. 2 times 1 is 2, so we know it's factored correctly. And it's still all over x minus 1 and x plus 1. Multiplication. X minus 1 is in the numerator. In the bottom now, I can see they have x in common, so I'm going to pull out an x as a my GCF. Leave me with 3 plus x plus 1. Let's double check by multiplying. 3 times 3x times x is going to be 3x squared. X times 1 is x, so we have factored correctly. Now let's cross cancel. I have a 3x plus 1 here, and I have a 3x plus 1 here, so that we'll be able to cancel diagonally. I have an x minus 1 here, and x minus 1 here. That was some more diagonal canceling, and remember there's a 1 left. So let's see what we have left. In the numerator, we have 2. On the bottom, we have x plus 1. Okay, that's the only thing we have left in our first fraction. We're going to be multiplying by 1 over x. 1 over x. Yeah. Okay. Our numerator is going to be 2. And the denominator is going to be x plus 1. I have no idea why this is. Oh, why does it do that? Our final answer is going to be 2 over x times our final answer. All right, let's move on. Let's see if we can find a problem that's a little bit more challenging. And I see one that has a trinomial. Ugh, a trinomial. Okay, let's see. All right, we have 2x squared, 2x squared minus 11x plus 5. And it's all over 5x minus 25. And it's divided by 4x minus 2 over 10. Okay, we have a trinomial in our numerator, and it has to be factored. Now remember, factoring trinomials, this particular trinomial, when I teach factoring, tends to be a challenge for most students because there's a coefficient on the first term. And with a coefficient on the first term, you have to factor the coefficient and you have to factor the last term of the trinomial. But because I'm observant, and that's how I teach my students to be, I know that 2 and 5 are both prime numbers, which is a plus. But then both being prime numbers, you only have 2 factors. So you don't have to, oh my gosh, how do they factor? So that's the easiest part. Knowing that they're prime numbers, knowing they don't have 2 factors, they're easily factored. So let's go right ahead and get it done, okay? I need my 2 parentheses, ink. 2 parentheses, so I'm going to make my multiplication symbol here. I'm going to flip that. Now, I'm going to do everything in one step this time. I'm going to do all my factoring at one time. So pay attention because it's going to be a doozy. All right, let me do the bottom one first because that's pretty simple. 5 divides into both 5 and 25, so I can factor out a 5. X is going to be left. And I have a 5. I'm going to check it before I proceed. 5 times x is 5x. And 5 times 5 is 25, so I know I factored it correctly. Let's go over here. We're going to factor this numerator. I know they're both divisible by 2, so I'm going to pull out a 2. I have 2x left here and a minus 1. Now, the reason why I do the simple ones first, because if this trinomial was a little bit more challenging, seeing what you have that can possibly cancel will help you. Because if I look at 2x minus 1, I'm like, that 2x minus 1, 9 times out of 10 will help me factor the trinomial on top. or the x minus 5 might help me. I just have to figure out which one's going to work. So sometimes factoring the simple ones can help you factor the ones that's a little bit more challenging. So let's check before we go on. 2 times 2 is 4, which is at 4x, and 2 times 1 is 2, so that one's factoring. Now let's go back up to this trinomial. Here again, 2 and 5 are prime, so it can only be 2 and 1. So I'm going to do my 2 first. That's 2x I don't know if it's a tablet or what it's doing. Okay. 2x minus 2x and x. Now I'm going to factor the 5. Now I'm trying to get 11 in the middle. If I put, when I teach factoring, I say in order to check to see you factor correctly, you do inner and outer. So if I put my 5 here and I do inner and outer, I'm going to do 2 times 1 is 2 and 5 times 2. 5 times 1 is 5. Can I combine to get 11? No, so I want to put my 5 here. Now, my middle term has a negative sign, so I need them to both be negative, because when I multiply negative 5 times 1, I have to get a positive 5. When I multiply 2 times negative 5, that's negative 10. 1 times negative 1 times x can be negative x, which is going to give me that negative 11. And we'll look at it. As I mentioned earlier, I know how to factor. That's why I didn't use these little hints to help me. But notice, this cancels with that. So x minus 1s are going to cancel. Cancel. This x minus 5 is going to cancel that x minus 5. In my numerator, I have 10 remaining. In my denominator, I have a 5 and a 2 and a 2. Is that 2 inside out? What did I do? Oh. Does anybody see my mistake? I got a little carried away there. Got a little happy. A little happy, and I stayed all day. All right. Oh, it should have been 2 inside as well. And you know what, listeners, I went back and I checked. Oh, I know what happened. When I erased it, I erased my 2. That's what happened. I erased my 2 because my technology is not playing nice today. That's what happened. I did have a 2x there. That's 10 over 10, which of course equals 1. Now, when we started that problem, you would have never, in your wildest, you probably thought that the answer would have to be 1, but here it is. Whew, that was not nice to Ms. Campbell at all. At all. I don't want to write on the screen because then I have to force myself to get closer, and my tablet is acting up. Let's do one more. Trying to find one that's a little bit more challenging. Because I know when I teach and when I watch different videos, a lot of them do not pose a challenge. Oh, I see one. Okay, let's see. You want to change the color? You want to, let's get purple, shall we? Okay, here we x plus 2 over 7 minus divided by x squared minus 5x squared plus 6. Excuse me. And then we have the other guy, x squared minus 9x plus 14. All right. X plus 2 over 7 minus x divided by x squared minus 5x plus 6 divided by x squared minus 9x plus 14. All right. If we look at our first fraction, there's nothing there to cancel. There's nothing there to factor. So our first fraction is going to stay the same. Let's write x plus 2 over 7 minus x. We're going to change this to multiplication. We'll reciprocate. Do we want to reciprocate and then factor? Let's reciprocate since it's a little bit more involved. Let's reciprocate and we'll factor x squared minus 9x. 14. And later, if you were to flip or reciprocate first, you wouldn't get confused. Do the reciprocation first, especially when you have so many steps where you have to do factoring. Students refuse to do that, and it helps. Reciprocate now, you're ready to factor. And I think you can actually see what you're doing now that you're reciprocating. So we have x plus 2 over 7 minus x. Students like to take shortcuts, and shortcuts are not always healthy. I'm going to factor my new numerator. Luckily, I have no coefficient on my first term, so it's easily factorable. So I know this is going to factor into x and x. I need 2 factors of 14. That's going to give me 9. 14 has 3 factors, 1, 2, 7, and 4 factors. 1, 2, 7, and 14. 7 and 2 are the only 2 factors that can give me 14. So when I teach, I always say, just put the factors in first. Now, you need a negative middle term or a minus in the middle. Now, if you multiply two negatives, you can get a positive. If you add two negatives, you can get a negative. So to check, let's check. If I multiply my inner, it's going to be 7x. If I multiply my outer, it's going to be 2x. In order for me to get a positive 14, they both have to be negative, or they both have to be positive. But because my middle term is minus, they both have to be negative. Now, I'm going to show you how I check my factoring. Go to the side of your paper. You're going to do inner. So you're going to do the inner ones, which is these two. That's negative 7 times x is negative 7x. Negative 2 times x is negative 2x. Now, to check yourself, you say, will those add up to give me a negative 9? Yes. Will they multiply to give me a positive 14? Yes. So that means I'm factored correctly. All right, let's do the bottom. I tried to share with students how to double check themselves before they go for it. Just because you're going to answer doesn't always mean it's correct. If you're checking your steps as you go through the problem, you're more likely to have it right in the end. All right, here we go again. X has no coefficients, so it factors into x and x. Our term that we need to find out is a 6. Factors of 6 are 1, 2, 3, 6. Which pair would give me 5? 2 and 3. So that's what I'm going to put in here. 2 and 3. I'm going to check it again. The middle terms multiply together give me 2x. The outside terms multiply give me 3x. If I want those two to multiply, and I have a minus sign in my middle term, is the same concept. When I add those two, I'm going to get a -5. When I multiply, I'm going to get +6. So I know both of them need to be negative. Now we're ready to start canceling. Crisscross or up and down. Okay, let's see. All right, I can do this and this because they're up and down. I don't see anything else I can do just yet. So let me rewrite the problem. Maybe I can see something I'm not seeing it. I have x plus 2 over 7 minus x times x minus 7 over x minus 3. And I'm going to write one long problem. Now, I think I mentioned it at the beginning of the class. X minus 7 and 7 minus x are opposites. Why? In the x minus 7, the x is positive. In the 7 minus x, the x is negative. In the x minus 7, the 7 is negative. And the 7 minus x is positive. So these two can cancel, and that leaves a -1. I shared that with you the very first lesson when we were simplifying fraction expressions. Whenever you have opposites, they equal -1. So now I can go ahead and multiply. And when you have a -1, we simply just stick the negative out in front. X plus 2 over x minus 3. X minus 3. And it's your final answer. You have to be observant. You have to be observant. All right, that was a real challenge. I hope you were up to it. I think I got a few minutes. I can do one more. What I like to do is do challenging problems. So when you say, oh, students freak out when they see a problem, I have so many things going on. So my goal is to do problems that are challenging. I know when I would help my daughter and she would be looking up problems and they don't really, and there's something that she doesn't understand. It's like, Mommy, why did I? They don't focus on what the student needs. They're just doing the problem, covering the concept. But I like to make sure I'm doing it so my student understands. All right, I found a hunky-dory one. So this is going to be the one that takes us out. It's the hard one. It has a lot going on, so I hope I don't fumble in the process. Oh, this one you see up there? Okay, there we go. Oh yeah, I like this one. Okay, here we go. Let me see if my thingy's going to do any better. I like right now. Let me see this one. Oh, now you're going to act right, huh? Okay, let's see if it's going to do better. Okay, let me see here. Let me put my finger in so I put my eyes go all over the place. Okay. We have 30. See, it's still not going right. 36 n squared minus 64 over 3n squared plus 10n plus 8 divided by 3n squared minus 13n plus 12. Okay, let me check. 3n squared minus 64, 3n squared plus 10n plus 8 divided by 3n squared minus 13n plus 12 over n squared, that's an n, minus 5n minus 14. All right, that's easy. First thing I notice is difference of squares. I know my perfect square. I see difference of squares right there in that numerator. So let's go ahead and factor. Remember, difference of squares factors into sum and difference. We're going to take the square root of 36, which is 6. The square root of n squared, which is n. And I'll put 1 in each parentheses. Then we take a plus sign and minus sign. The square root of 64 is 8. Put 1 in each parentheses. And that is done. All right, now we have 3 trinomials we have to deal with. Okay, so we know this is going to factor into 2 trinomials. So we know 3 is prime, which is lovely. So it can only be 3 and 1. We need to get 10 in the middle. So we need to factor 8. Excuse me, 8. The factors of 8 are 4 and 2, 8 and 1. We need to arrange them so that when we multiply, we can get 10. So 4 times 3 is 12. Plus 2 is, so it's going to be too big. So if we put 4 here, it'll work. We have 4, we have 2. Plus, because they're both positive. Let's check it. 4 times 2, 4 times 1 is 1. 3 times 2 is 6. Plus 4 is 10, so I know it's factored correctly. Now, we had a little trouble over there, but let's come over here. And 9 times out of 10, one of these factors is going to help you factor the top. But let's go ahead and jump down and do the bottom because that's going to be easy because there's no coefficient. There's going to be n and n. Yay. Well, 2 factors of 14 can give me 5, 7, and 2. I need a -5, so my bigger number needs to be negative. And there we go. Oh, do we have to bring it down some more? Oh my goodness, come on. Who can tell me what? I missed a step, but I'm not gonna say anything yet. Let's go ahead and do this. We know 3 is prime, so it's gonna be 3n. And then we need to get 12. I said it a few minutes ago. We need to get 12, so we need to have, actually we need to get 13. So we want 4 times 3. You can also subtract. 6 times 3 is 18. No? 4 times 3. Wait, 3 times 3 is 9. Here you go, here you go. 3 and 4. 3 and 4. 3 times 3 is 9 plus 4. It's 13. And they both need to be negative because we want a positive 12. Now, what I did not do, I have not flipped yet. I factored by that. Remember, I try to do things different order every time. Now, before I flip, I want to look right here. Now, if I look at both of these right here, what do you notice? They both have something in common still. Although what difference of squares, they still have something that they could do something with. So, okay. All right. Let's go ahead and flip or reciprocate over here. So n minus 7 goes up top. N plus 2. In the bottom, we have 3n minus 4. And we have n minus 3. So I just flip right here. That's my flip. Now here, I can factor some more. out a 2, leaving me with 3n plus 4. I can also take out a 2 here, leaving me with 3n minus 4. So as I work through the problem, I'm not seeing everything in any particular order, but I'm observing enough to make sure that I factor everything, because as I consider canceling and I'm looking at my problem, I have to make sure that there is a possibility of canceling. So as I look at my sum and difference, like, oh, they still have 2 in common. So that's what I did in this step right here. I pulled out a 2. My 3n plus 4 on the bottom is still there. And I have n plus 2. N plus 2. I think what's happening is when I get to the bottom of the page, it does that. That's what's happening. Okay. All right, now we can do some cross canceling. We know, of course, we have the multiplication sign in the middle. The multiplication is right here. So we're going to cross cancel. Let me change color so I can show my cross canceling. I haven't used orange today, and I like orange. Let's use orange, shall we? All right, so let's look diagonally and see what we can get rid of to make our problem a little smaller. Okay, if I look up and down, I see that this can cancel with this. 3n minus 4 can cancel with this 3n minus 4 right here. This is up and down, that can cancel. Now, if I write what's left, I have 2 times 2 on this side over 1. On that side, I have n minus 7 over n minus 3. I know this problem was quite involved, so I suggest for you to better understand it, go back through it and just listen to it step by step. And then you might try working it as you do it. So we have 4 n minus 7 over n minus 3 is our final answer. All right, so today we have multiplied rational expressions. Our next lesson will be adding and subtracting rational expressions with like denominators, and we're also going to look at how to find the LCD. Now, I know finding LCD with fractions sometimes can pose a challenge, but with the next lesson, I really need you to put your mind in focus, because finding the LCD with rational expressions is a challenge. I have tried my best to make it simple, and I'm going to try to bring that across to you. So be ready, because adding and subtracting rational expression comes next. So I'm going to stop sharing my screen so I can say a proper farewell. All right. Well, it was fun dividing. Here, if you know how to multiply rational expressions, you can divide. You just have to remember those 1 or 2 things that you have to do. So I just want to say thank you for sharing and being here. And next time, we're still doing it like it is, rational expressions. All right, you have a great day, and I'll see you again soon.